So, taking the determinant of a 2 by 2 matrix is not overly complicated. What about taking the determinant of a 3 by 3 matrix? Taking the determinant of a 3 by 3 matrix is a little bit different and has a pattern to it. In order to take the determinant of a 3 by 3 matrix, we will start by taking the entry A and multiplying it by the matrix, the 2 by 2 matrix that is left by actually deleting its row and its column. So we will multiply A by the determinant of the matrix of EFHI. That 2 by 2 matrix times A will be our first value that we're looking for. That will be the first value in our sequence that we're going to look for. Next, we actually are going to subtract our middle term. And our middle term will start by looking at the entry B and multiplying it by the determinant of the matrix, of the 2 by 2 matrix left by deleting its row and its column. So we will look at the determinant of the matrix DFGI. Notice that's shown in our formula below. And again, this middle piece we will always subtract. For our last piece, we will add normally, and we will look at the last entry, C. And again, we will multiply it by the determinant of the 2 by 2 matrix created by deleting its row and its column. That means we'll look at multiplying C by the determinant of DEGH. And again, on this last one, we will add normally. So the only one we actually look at reversing the sign of is the one in the middle. Let's try our new formula for finding the determinant of a 3 by 3 matrix by starting with problem A. We'll start by looking at the entry, the first entry, 8, and multiplying it by the determinant of the matrix that's left over by deleting its row and its column, which leaves us with the matrix 0, 3, -1, 2. Now we'll subtract the middle piece and we'll look at the second entry, which is -2, and multiply it by the matrix that's created by deleting its row and its column, which will leave us with 7, 3, 5, 2. Now notice something odd happens here, because we have minus in front of that -2. That was our entry for the middle piece. So that will turn into a plus or +2. Our last piece here is automatically a plus or a positive always, except for on our last piece, notice that we do already have a -4 that's supposed to be in front of our last matrix. And again, we'll delete -4's row and column, leaving us with that we're going to multiply by the determinant of the matrix 7, 0, 5, -1. So let's see what happens here. Well, on our first group, we have the 8 that's in front of the matrix. We just have to multiply by the determinant. Well, let's work out the determinant for our first 2 by 2. So we'd start out with 0 times 2, which is 0, minus, well, we have to multiply the other cross product, which is 3 times -1, which is -3. So notice we have a 0 minus a -3, which actually will turn into a +3. So for our first piece, we have 8 times 3, which is 24. Now let's look at our middle piece. Our middle piece had a minus a negative 2, which turned into a plus or positive 2. So we have a plus or positive 2. Now we just have to look at finding the determinant of the matrix. Well, we start out with the first cross product, which is 7 times 2, which is 14. And then we subtract the other cross product, which in this case is, let's see, 5 times 3, which is 15. So we end up with 14 minus 15, which is negative 1. So we added 2 out in front of that, and then we have our determinant, which is negative 1. So 2 times negative 1 is negative 2. Now on to our last piece. Notice we have that we're adding, but it's a negative 4. So we have a negative 4 times whatever we get for our determinant. So let's look at the determinant. Looking at the first cross product, we get 7 times negative 1, which is negative 7, minus our other cross product. Well, our other cross product is pretty straightforward. It's 0 times 5, which is 0. So we end up with negative 7 minus 0, which is just negative 7. So we end up with negative 4 times our determinant, which is negative 7, which gives us a total of positive 28, because a negative times a negative will give us a positive 28. Now we've got all of our values from each of the 3 pieces of the determinant for this particular 3 by 3. So all we have to do is add and subtract normally. So we have a 24 minus 2, which is 22, plus 28, which is a total of 50 for our determinant for our first 3 by 3 matrix. Now let's work on problem B. Notice again, we want to take the determinant of a 3 by 3 matrix. So we'd first start out with the first entry, entry 2, and multiply it by the determinant of the matrix left over by deleting its rows and its columns, which would be the matrix 9, 0, negative 2, 0. Now with the second or middle matrix or piece, we would subtract, and we look at the middle entry, which is a 3, and look at the determinant made by deleting its rows and its columns, which would leave us with the matrix 1, 0, negative 1, 0. Now the last piece we always add, but the last entry is just a 0. So it won't matter what is inside of our last matrix when we delete the rows and columns, because 0 divided by 0 times anything, will be 0. So that means that this entire last piece here will end up being 0. So that piece won't even matter. Now backtracking to the first 2 pieces. Notice that when we go to take the determinant of either one, when we do the cross product of the first matrix, for the first part we'll get 0. But notice the other cross product is also 0. So 0 minus 0 will still end up being 0. So the determinant of this first matrix will end up being 0. So we will again end up with 0 times the 2 that was out in front, which is still 0. Now looking at the middle piece, the same thing's going to happen. We will again find the cross product of the first pair, which is 0, and then subtract the cross product of the next pair, which is also 0, to get the determinant, which is 0 minus 0 will give us 0 for the determinant. Well, if we get 0 for the determinant, even if we're multiplying it by a -3 that's out in front, 0 times anything will give us 0. So each of the 3 pieces for the determinant is 0, which means the entire determinant for this whole 3 by 3 is 0. And we'll see why later. There's actually a special rule for this type of matrix that we will learn later.